Hello students, so let us continue with our distributed computing classes. So the concept that we are going to study today is distributed file systems. So let us move forward. So in a computer system, a file is a named object that comes into existence by explicit creation. That is, you have to actually create the file as a user in order for the file to exist. Then is immune to temporary failures in the system. So if there are any failures, unwanted failures in the network or in the system itself, then the file must keep on existing, then persist until explicitly destroyed. So the file need to exist until the user himself or herself wants to remove or destroy it. So the features we have here provides an abstraction of a storage device. So a storage device will have various contents. So in order for it to be represented properly, we need a file system. So frees the programmer from concerns on space allocation. So whenever we create a file, we don't need to actually bother about in which corner of the space the file is going to exist. Then frees the programmer from concerns on layout of the secondary storage device. So things are going to happen automatically. You just need to create the file, make sure there is enough space for the existence. Then a distributed file system supports the following. So permanent storage of information, which is one of the objectives of a secondary storage device. Then sharing of information. So file created by one application can be used by a different user at a later time. So we are able to easily share the collection of information with the help of files. Then user mobility allows the users to work in different nodes at different time. This is mostly in terms of distributed computing, where we can sit down in any of the machines and still get the same environment. Then availability, multiple copies of a file in different locations as a fault tolerant measure. Okay, so if there is a particular crash in a particular machine, but the files must still exist in the entire network, thanks to the concept of replication. Then fifth is diskless workstations, where you don't have a storage device in your own workstation where you're using, but you can take advantage of a remote one. Okay, so it's more economical and less noisy and generates less heat. Okay, so then the services provided by distributed file system are as follows. Storage service, of course, allocation and management of space in secondary storage device. Then we also have a logical view of the entire storage system. So this is also known as disk service and block service. Then we come to true file service. That means we are able to manipulate with the files that we create. So after creation, we can delete it, we can modify it and access it whenever required. So all the primitive file operations must be there in order for it to have a true file system. Okay, then name service, also known as a directory service. So mapping between text names of files and references to the files. So whenever we create a file, we give our own names. However, the machine may give its own reference name for it to be accessed. This is important because if we have multiple machines and multiple users, suppose they create files with the same name, and then there may be confusion, right? There may be clash. So in those cases, it's totally fine in case of distributed computing, because the entire system is going to take care of files with the same names, because there will be some reference names provided to the files in order to distinguish between them. All right, so then we come to file models. So we can have unstructured and structured files. So in case of unstructured files, it's basically a file consists of sequence of bytes. Okay, so operating system is not interested in the information stored in the file. So it's very user oriented files that we have. So maybe the user has certain semantics put inside a file. However, the operating system has need not know about it. Okay, the interpretation of the meaning and structure of the data stored in the files are entirely up to the user, okay, or to the application program where the user is going to use that file. Okay, the semantics of the particular file only needs to be known by the user. So example is operating systems like Unix and MS-DOS. Then we come to structured files. A structured file is an ordered is a file where the contents will be like ordered sequence of records. So a unit of information stored in those files will be called a record. Okay, so a record of different files of the same file system can be of different size, and a record is the smallest unit of data that will be available, and a file system read or write operations carried out on a set of records. So what you mean by that is, if you have to do any modifications to the file, then you basically have to do a particular read or write operation on the entire record in that particular file. Okay, so in the earlier case it was just a sequence of bytes we had, but here we have a sequence of records, and by records you mean a collection of information that represent a particular entity. Okay, then we come to, okay, in case of structured files you can have non-index records and index records. I think we already know the concept of index. If we look into the concept of arrays, then we already have indexes where the position of a particular element is specified by some values which are known as indexes. So same concept is applied here. In case of non-index records, a file record is accessed by specifying its position within the file. Okay, so there is no indexing involved there. We have to directly give the offset of a particular location of information. But in case of index records, records have one or more key fields and can be accessed by specifying the values of the key fields. So it's something like a key value pair that we have to follow. Okay, and based on the keys we will get the values associated with that key. All right, so then we go to mutable and immutable files. In case of mutable files, an update operation on a file overwrites its previous content. Okay, so this is quite normal. Whenever we use a particular file, we try to make changes to it, we try to add new contents or remove earlier ones. So those are immutable files. But in case of immutable files, what happens is a file cannot be modified once it has been created, except to be deleted. So what it means is, when you create a file, you basically cannot manipulate with that file anymore. Okay, but then if you have to make any changes, what will you do? All right, so for that we can move to the next point. File versioning approach is normally used to implement file updates. So whenever you have to make any changes to the file, you basically create a new file and give a version to it. So maybe the first file had version 1, then the second file had version 2, and so on. Okay, each file is represented by a history of immutable versions. So if you look at a particular file and if you find that there are multiple versions associated to it, that means that file must have been modified many times. Okay, so how to reduce the uses of storage space in case of immutable files? Yeah, this is very important, because if you create a file and if you have to make changes to it, of course you are going to create new files with new versions. Now it will capture a lot of space, right? So what you do? So this is a question that is thrown to you, but maybe one of the ways we can do it is, maybe we can remove the very earlier version files that we had. Okay, only keep the maybe the last 3 latest files and so on. Okay, so different concepts can be used, so you can explore on that. Okay, so then we come to file replication. A replicated file is a file that has multiple copies, with each copy located on a separate file server. Please try to make it clear, like whenever we talk about replication, we say that the entire copy is going to be placed in multiple locations. Okay, it is not like we have a single file, we split it into 3 parts and we keep 3 parts in 3 locations. That is not. Okay, we have to actually create entirely new copy of that file and keep it in remote places. I think we have talked about replication before also. In case of Hadoop, whenever you install Hadoop, you will find I think the default value is 3. So whenever you create a file, you actually create 3 copies of that particular file. Okay, so in various applications in distributed computing, file replication is always seen, and it is a very good fault tolerant mechanism, because if some machine crashes or there is a network failure, link failure, and so on, that file still exists thanks to the replicated files that we have. So whenever that particular machine that had that file comes back to life, it can just copy the replicated file from a remote server, and we again get the availability of that particular file. Okay, each copy of the set of copies that comprises a replicated file is referred to as a replica of the replicated file. Okay, so these copies will be known as replica. So there are differences between replication and caching. You may get confused at times, so how to draw a table of it. So replication is associated with a server, so a server is going to manage that in order for the availability of the file. But in case of caching, it's basically a client oriented. For example, like in a browser, a user is a very client associated application, right? So in those cases, caching may be applied to speed up the process of fetching and interacting with the website. Then replication availability and performance requirements are related. Okay, so you have to be very careful whether you want to have more replication, but if you have more replication, then the space allocation will also be more. Okay, and more management has to be done whenever there is a change applied to a file. But in case of caching, depends on the locality in the access pattern. That is always caching is done in a local machine where the user is currently working, so that's the difference. Then in case of replication, a replica is more persistent, widely known, secure, available, complete, and accurate. So it is a very intensive feature that we have in order to keep everything smooth, whereas in case of caching, a cached copy is not. So caching does not give all these features. It is a very temporal relief that is given to a particular user. It's a very temporal feature that is provided to speed up the things. Then in case of replication, non-contingent upon a cache copy, and in case of caching, contingent upon a replica. Periodic revalidation with respect to a replica is required. So what it says is, in case of replication, you don't need to keep on checking the various changes that are taking place in the files, where in case of caching, you have to always have a periodic revalidation whether the content is still the same or not. Okay, so these are the various differences we had between replication and caching. So I'm going to continue in the next video. Thank you.